All right, take two. So I just want to go through the key of the Nearpod activity from today. Remember, here's the Nearpod activity we're doing today. It's about the history of our understanding of the atom. Please don't panic if it was a struggle. We're not going to go through all the information in detail on any sort of assessment. Just kind of give you an understanding of how we know what we know about the atom. All right, I'm going to let this load. Remember, we always go with Google, log in with our Google account. That way, it takes our first and last name, keeps it, automatically submits it for us along the way, which is good in case we forget. We confirm that it is you. Remember the first part, we were just going through how was our understanding of atoms changed over time. That's the kind of the point of the lesson for today. And by the end of the lesson, you were able to explain one way our understanding of the atom has changed. So today we're talking about the atom. We're going to get to how the atomic model has changed over time. We're going to watch a video about the history of the atom, and then we should be able to explain a couple ways the atom model has changed. So the first thing is simply when you think of an atom, what comes to mind? So what I did is I actually just drew an atom. This is the Bohr model, which you'll understand in a few minutes. But again, I just drew what I perceive as an atom. It doesn't have to be a great drawing, but you should have something. Make sure you submit it. And then we'll automatically go on to the next one. Again, an atom is a basic unit of an element. Everything is made of atoms. You are, your table, air. But our understanding of atoms has changed dramatically over the last couple of years. We're going to talk about the 3D models that represent how the model has changed. I'll talk about them briefly and then we'll move on. So here's the 3D model. I'm not going to play it because it just plays. It's the same thing. Here's the original model by Democritus, who thought of kind of a solid sphere model, where the atomos model can be indivisible. Here we have the Thomson model, where we have electrons and protons intermixed like cookie dough through the whole atom. Then we have kind of the Rutherford model, where we see an atom or has a nucleus or a big mass in the center. We then see the kind of the Bohr model in the last two, and even the modern theory we see as the atoms are basically a nucleus with a cloud of electrons surrounding them. Again, it asks you an open-ended question, and you can record it, make a prediction, describe how the atomic model has changed over time. Again, you should be able to record if possible. Our understanding of the atomic model has improved over years as our science improves as well. So if you're not able to record, you can always hit the delete. Maybe you recorded something already, but you should be able to record. Our understanding of the atomic model has changed as we understand the parts that make up the actual atom. And again, once you're done, hit stop, submit, it'll automatically move you through. Gives you another open-ended question. Based on our technology, why has the atomic model changed? So I showed you this picture about viruses. And again, these 300 years ago, we couldn't see these things, let alone 2,000 years ago. So I gave the answer of, as our technology improves, we can see smaller and smaller objects, which helps our understanding of the atom. And there you go. Well said. Well, thank you, Mr. Ray. Again, when you're done recording or typing, submit. Okay, then explain on the next slide. Now I'm not watching the whole video because you can watch it on your own. So I'm actually just going to skip it because it's going to save me 5 minutes of waiting for the video that you already watched. Okay, you had to write down one thing you learned from the video or the history of the atom, like the fact that the history changes. Everything is made of atoms. Atoms don't touch each other. Anything you might have learned. Some people chose pictures to include, but make sure you've added something onto this table. Okay, so let's learn a few more. Atomic theory timeline. Pardon me. So it's going to go through. I'm going to go through. It opens up this tab. I don't like the way it's opened, but I didn't create this. I just kind of stole it, so I wouldn't have done this. So review the theory again. Democritus is the one who thought about the atomos unit, or the small structure of indivisible material. But then water had its own kind of atom, or air had its own kind of atom. So although he had a good basic understanding, he kind of missed part of it, and that may have impacted his ability to explain it, which caused it to kind of lie in obscurity for almost 2,000 years. The theory that existed for the longest time was the Aristotle's theory of atoms or all matter being made up of a combination of fire, air, water, and earth. Unfortunately, that's a way inaccurate description of the way matter works. But Aristotle was so respected that actually belief lasted for about 2,000 years until the next experiment. Scientists started to look at it and evaluate it. Remember, Dalton was one of the first ones to look at the Democritus model again. He had the solid sphere kind of model where, yes, they are individual atoms, but they are different from each other. Thomson expanded on that when he looked at the way charges affected an atom. And he said it's kind of like plum pudding or a cookie dough or a chocolate chip cookie, where you have all these positive charges through the atom and then you have interspersed these negative charges throughout. Rutherford is also known as the father of the nuclear era because basically what he did is he fired those particles at the atom. Notice that they bounced back, so there had to be something in the middle of that atom, which he called the nucleus. So his analogy is kind of like a cherry with a pit, where the pit's for the nucleus and the rest of the cherry is the atom itself. Then we had Niels Bohr, who came along, and he came up with the middle was already decided about the nucleus with the protons and the neutrons. What he gave us is kind of the planetary model of electrons, that electrons orbit the nucleus at certain energy levels, and they can move back and forth through the energy levels. And today we have our modern cloud theory, which kind of expands on this, where we do have a nucleus. That really hasn't much changed. But our electrons, because of the weird behavior, they almost have kind of like a wave property to it. They exist in what's called an electron cloud in random patterns. We can't really predict where they are, where they're going to go. So we call them like a cotton ball or a cloud, where the electron can be anywhere around that shell. All right, next slide. We're going to do fill in the blank activity. I'm actually going to go through this for you. Or with you. I'm going to move myself over here. Trying to get dizzy in the process. So the first one we talked about was Democritus. And his was the atomos belief, where all matter is made of these small hard particles. But his confusion was that water had water atoms and dirt had dirt atoms, where that kind of caused a confusion with his theory. So maybe part of the reason why I wasn't accepted as so much. Following behind that was Aristotle's belief that all matter was made up of a combination of four elements: fire, air, water, and earth, kind of like the Avatar theory. And that's the way it stayed for about 2,000 years until Dalton started to relook at Democritus's theories. And when he looked at that, he said, yeah, I believe that the objects are these solid spheres. Where he took it further was that he was able to break apart materials that Democritus was not. Like you can see that water broke apart to hydrogen and oxygen. So even though matter is broken, it can be broken into smaller objects, they can recombine in a variety of ways to form new matter. Then we had Thomson came around, and he had the chocolate chip cookie analogy, where it was an atom with positive particles spread throughout and negative particles spread throughout. Then Rutherford came along and he started shooting the alpha particles of the nucleus. He kept bumping again across the nucleus, and he was kind of the father of nuclear theory, where you have protons and neutrons in the atom, in the nucleus, and then electrons scattered around the outside, around the outside, around the outside. Then we have Bohr. He had the model. Bohr's planetary model is that, yes, these electrons orbit the nucleus, but they do it at various energy levels, kind of like the orbits of planets. That's why it's called the planetary model. And today we have our modern cloud model, where electrons do not orbit the nucleus in neat planet-like orbits, but they do move at high speeds in an electron cloud around the nucleus. And when we're done, we hit done, and we see we got them all right. For which experiment is being presented, if you look at the experiment, it is Rutherford's experiment. They're shooting alpha particles at this wave. If you see how they hit this board, sometimes they deflect, sometimes they bounce back. That showed Rutherford that there had to be something there in the middle. So I circled Rutherford's with my marker, and I submit, and it allows me to move on, or it should. And then finally, we evaluate what we learned. Start with an open-ended question. How would you explain currently accepted atomic theory? So I kind of drew an atom. So I have my nucleus and I have the electron cloud. Or I can just use a text box and say an atom is a nucleus surrounded by orbiting electrons. And finally, they ask you the question, how well do you understand the history of the atom? Well, I'm well, not perfectly, but well, and submit. And then one more open-ended question is just for me. There's no real reason to answer it. I won't grade it. What questions do you have about the history of the atom? So why did it take so long for scientists to try to disprove Aristotle? Why did we sit in ignorance for 2,000 years? And then you can submit that, and you are done. All right. If you have any questions about that, please reach out. But that is a key that will help you walk through it. Also show you the right answers to it. If you have any questions, please feel free to ask me. Otherwise, have a grateful day.